Hi there, in this video I'm going to show you how to use the applet for multiple means, so more than two means. So this is the chapter 9 handout. So this is where we do the MAD distribution, F distribution, and ANOVA analysis of variance. This handout is posted in Canvas, so be sure to follow along with this handout, print it or have it ready on a different screen. So what we're going to do is access the Diets2 file. It's in StatCrunch or also it's on the textbook data files. And so you can go through this on your own. The research question, what are the observational units, the variables, null and alternate hypotheses, and so now we want to look at the different statistics to do a simulation. And just as before with chapter 8, there are three possible statistics, the max minus the min. But remember, this ignores all the other differences, so that is not a very good statistic. We are also going to do the MAD statistic, mean absolute difference. And lastly, the theory-based approach, which is the analysis of variance, the F distribution. And that's the one that it can be predicted using a theory-based approach. The MAD is not a well predictor, and so that's why we use the F statistic. And the parallel for a categorical response is the chi-square. So let me show you how to use the applet for this data. So we need the randomization test for quantitative response. So when you go to our applet collection, we have randomization test for quantitative response and for categorical response. We are dealing with means, so we're going to look at the quantitative response. So click on that. Let's clear this data and let's go to our textbook data file. So for modules, go to the applets and then textbook data files. Once you're there, we're going to go to chapter 9 and our data is Diets2. This data is also available in StatCrunch, so you can access it from there. So I'm going to copy it and paste it onto my applet and click on use data. If you happen to copy a table, there will be a button here that will say use table. We don't see it here because this is quantitative response. For categorical response, that's where you see, that's when we use tables. And here is our 4 different diets. We have Atkins, Zone, Ornish, and Weight Watchers. And to show the box plots, we can click on box plots. And right now, notice that our statistic is the MAD, but if I change it, I can change it to the max minus min, and this is my statistic. So I could run a test of significance to see how likely are we to look at that difference again, to get that difference again. So if I look at 1,000 simulations, here's my 1,000 simulations. Notice that it's slightly skewed right. There's a slight right tail. And so if I wanted to see the p-value, my statistic is the max minus min. So it's 2.641. So I'm going to put that here, 2.641, and count. And this is a very high p-value, 0.5360. So it is not a very good statistic. So that means there's not one diet that's better than the other. If you look back on our handout, the null hypothesis is there is no difference in diets. All resorts are the same or similar. And the alternative is there is a difference in weight loss results, meaning at least one diet will have greater weight loss results. Well, based on this p-value, this is a large p-value, so we fail to reject the null, which means that the null is plausible, so there is no difference between diets. Let's change it to the MAD, mean absolute difference. N is 1.369. So that means we are doing there are 4 of these, 4 differences. I'm sorry, 4 means, so that means you're going to have 6 differences. So when you find the average of the absolute of all the possible differences, you get 1.369. So to see that, let's put 1.369 to see our test of significance or p-value, and we still get a pretty high p-value, 0.5880. When I did it for the handout, we got pretty close for the max minus min, and for the MAD we did get 1.369, and when we got the p-value, I actually got a higher p-value when I did this handout. And so, but still it gives us the same conclusion. We failed to reject the null. The null is plausible, which means there is no difference in diets. So that is how we find the p-value. And now our last statistic is the analysis of variance, the ANOVA. And ANOVA compares the variation between groups to within groups. But to find the ANOVA, the F statistic, we go down to the same applet and select F statistic. So F statistic is our ANOVA, analysis of variance. And notice that the F statistic is 0.536. And over here in the handout, this ratio is explained a little more. The applet F statistic is 0.536, which is close to ours. Ours was 0.58 here. So that's the between group variability and the within group variability. The 22 came from doing on average how many people are per group, and in our notice that 26, 20, 26, 21. So it's 22 seems to be a fairly good number to capture those sizes, so that's why we have the 22 here. And so the between group variability and the within group variability, and we use the descriptive statistics applet to find these values. So that was our F statistic, 0.58, which tells us how many times one is larger than the other. So here, let's go do our test of significance for this statistic. So 0.536 and count. So we still get a very large p-value. The nice thing about the F statistic is that it is a theory-based approach. So notice how it says overlay F distribution, so I can click on that and it gives me a very good approximate of the data. So the F distribution is kind of like our normal distribution for bell-shaped data. So this is our F distribution, and notice the p-value. The exact p-value is 0.6588, which is very close to the approximate that we got. And so as long as we have at least 20 in each group, which we do, we have 26, 20, 26, 21, then we can use the theory-based approach. The theory-based approach is the F statistic by clicking this box. You are doing theory-based approach. I hope that this helps explain the ANOVA applet, and it's very similar to the categorical response applet. The difference is are statistics. In the categorical, you'll see MAD, max and min, and chi-square instead of F statistic. Thanks for watching.